In this lesson, we're going to look at how to create equivalent decimals or equivalent decimal numbers. I will do this through showing models to show you in a picture form why it works, but then we'll just look numerically to see kind of a shortcut of basically how you create equivalent decimals. It's actually very simple once you get the hang of it. First of all, let's look at the models to see exactly what's happening. I have a square up on the board that is divided into 10 equal parts. I'm going to shade in a certain fractional part of the square. So here's 1/10, 2/10, 3/10, 4/10 of the square is now shaded in. As a fraction, of course, that is 4/10. But since we're trying to see how to make equivalent decimal numbers, we're going to turn this into a decimal number. So 4/10 as a decimal number is 0.4. A 4 in the tenths place, and they're both pronounced exactly the same way. 4/10, 4/10. Now, on the square to the right, I want to shade an equivalent amount of this square compared to the first square. So I'm going to shade in the next square in pink. So once again, I want to shade in an equivalent amount. So I'm going to highlight or shade in the exact same amount. And now to prove that this really is the same amount, I'm going to move this square over top of the other one, layer it on top. And you can tell that the pink is layered over top of the green, and the exact same amount is shaded in. I'm going to move this back over here. So by looking at the picture, you can tell these really are equivalent or equal amounts shaded in, same size square. As a fraction, this square is divided into 100 equal parts, so the denominator is 100. And 40 of the individual squares are shaded in, so that would be 40 hundredths. So once again, I want to convert that to a decimal number, and that would be 0.40. So in essence, 4/10 is equivalent to 40 hundredths. Now, if we forget about the pictures themselves or the models and just look at the numbers to see what's happening, you can see that all I did to create an equivalent an equivalent decimal number for 4/10 is I took 4/10, but all I did was add 1 0 to the end of the decimal number, and that creates an equivalent decimal. This works no matter what the model looks like or what the decimal looks like. So on this next model, I am going to shade in 9/10 of the first square. So as a decimal number, that is 0.9, 9/10. And on the second square, I'm going to shade in an equivalent amount. Once I get this shaded in, I'm going to put one square over top of the other so that you can tell by just looking at the pictures, these really are equivalent amounts. The red is layered over top of the green, so they are equivalent amounts. So we know that the shaded parts are equivalent. Well, now this one is divided into hundredths, and there are 90 individual little squares shaded in. So 90 hundredths as a decimal number is 0.90. So the two decimal numbers are equivalent to each other. So all I had to do mathematically was take 9/10. See, there's the 9/10, and all I had to do to get an equivalent decimal was add 1 0 to the end. If you start with a decimal number that already has a 0 to the end of it, for example, let's take, I'll do a little bit more. We will shade in 80 hundredths of this picture or model. So 80 hundredths, 0.80. And we're going to shade in an equivalent amount on the second square. So there would be 8 of those. And just to check our models, let's put the green one on top of the red one. And they are indeed the same exact amount shaded in. As a fraction, this one is divided into 10 equal parts and 8 of them are shaded. So as a decimal number, that 8/10 is written as 0.8. So 80 hundredths is equivalent to 8/10. Well, this time I started, my original decimal number had a 0 on the end of it. To create an equivalent decimal, all I had to do was take the 0 off of the end of the number. So 80 hundredths is equivalent to 8/10. And basically, in a nutshell, that's all you have to do. You can either, to create equivalent decimal numbers, if there are zeros already at the end of the decimal number, you can just simply take them off to create an equivalent decimal number, or you can add zeros to the very end of the decimal number. So we're going to start with one that already has zeros to the end of it. So if I took one of them off, an equivalent decimal for 800 thousandths would be 80 hundredths. If I took 2 zeros off of the end, an equivalent decimal for 80 thousandths would be 8/10. So let's look at one that doesn't have any zeros at all at the end of the decimal number. And this time I'm going to have one that has a whole number with it, 7 1/10. Don't let a whole number freak you out. You do the exact same thing. I'm going to take the original decimal number, and to make an equivalent decimal, I can add 1 0 to the end, or I can add 2 zeros to the end. I could add 3 zeros to the end. I could add 4 zeros to the end. I could add 50 zeros to the end, and it would still be equivalent to 7 1/10. And really, that's all there is to making equivalent decimals. Either take a decimal number without zeros at the end, and to make an equivalent decimal, add zeros to the very end of it. You can add 1 or more zeros to the very end. If you start with a decimal number that already has zeros to the end or on the end of it, like this one, you can simply take zeros from the very end of the number. So this would be 0.0070. I took off 1 0 from the end. Or I could take off 2 zeros from the end. 0.007. Now, at this point, you may be looking at this final example I gave and asking yourself, but what about these other 2 zeros right here? Well, these zeros are not at the very end of the number. If you have zeros in between where the decimal point is located and another digit, you cannot remove those. Those have to stay the same. Remember, it's only at the very end of the number where you can either take the zeros off or add more zeros to the end. So let's look at just a couple of examples. So is this true or false? True or false? Is 1 4/10, or I should repeat that, 1 4/10 is equivalent to 1 400,000. Now, is that a true or false statement? Okay, hopefully you saw that the answer is true because my original number was 1.4. To get the equivalent decimal, I just added 2 zeros to the end, and since it was at the end of the original decimal number, they are equivalent to each other. Let's look at another example. So you're trying to decide, is this true or false? 7 hundredths is equivalent to 70 hundredths. In this case, the answer is false. They are not equal to each other. This symbol means is not equal to. If you look at the original number, 0.07, I have to start off with 0.07. Even though I did add a 0 to the end, I totally eliminated the 0 that was in between the decimal and the 7. Therefore, they are not equivalent to each other. Let's look at just one more example to determine if this is true or false. 14 307 thousandths is equivalent to 14 3,070 10,000ths. So, is this a true or false statement? The correct answer is true. They are equivalent to each other. The original decimal number, 1.4.307, appears right here. 1.4.307. They are identical to each other. The only difference is at the end of the number, I added 1 0. So if the 0 is added to the end or taken away from the end, they are equivalent to each other. Hopefully this helps you understand how to create equivalent decimals.